The 2020 Friar Contest, Question 2. In the diagram, rectangle JKLM is drawn with its vertices on the sides of triangle PQR so that PJ equals PK equals 5 meters, JQ equals KR equals 50 meters, KL equals 40 meters, and QR equals 66 meters, as shown. Part A reads, what is the length of LR? We'll look at a couple of different approaches to solve this. First up, we'll look at using a 3-4-5 triangle. So let's first observe that angle KLR right here is a right angle, which means that triangle KLR is a right triangle. And this right triangle has a leg of length 40 and a hypotenuse of length 50. Now, for those who are familiar with 3-4-5 triangles, we can recognize that this is a 3-4-5 triangle scaled by a factor of 10, which means that the LR side here is corresponding to the 3 side of the 3-4-5 triangle. And since we're scaled by a factor of 10, then we should get that LR equals 30. I would highly recommend being familiar with 3-4-5 right triangles, as they appear often on competitions, and many times recognizing them will help solve the problem a lot more quickly. Now, that being said, let's take a look at an approach to solve this problem without knowing about 3-4-5 right triangles from the beginning. And for that, we'll use the Pythagorean Theorem. First, we start off again with recognizing that KLR, the angle, is a right angle. So therefore, the triangle KLR is a right triangle. And since it's a right triangle, we can apply the Pythagorean Theorem. So we know that says that KL squared plus LR squared, so the sum of the squares of the legs, equals to KR squared, the square of the hypotenuse. So we have an equation here. Now let's substitute the known values. We know that KL equals 40 as given in the question, and KR equals 50 as given in the question. So substituting the values in, we have 40 squared plus LR squared equals 50 squared. Now we can solve for LR using this equation. First, I'll subtract 40 squared from both sides. So we have LR squared equals to 50 squared minus 40 squared. At this step, I don't go and expand 50 squared and 40 squared because that will make the numbers bigger. Instead, I apply the difference of squares factoring to get 50 minus 40 times 50 plus 40 on the right-hand side. Now this is much easier to compute, as 50 minus 40 leaves us with 10, and 50 plus 40 is 90. So we have that LR squared equals to 10 times 90 equals 900. Now let's observe that LR as a value is a side length, so it must be a non-negative value. So therefore, from LR squared equals 900, we can take the square root of both sides and get that LR equals 30. Here, recognize that this approach also yields the correct answer that we computed in the first approach. However, in the second approach, it took much longer than using the 3-4-5 triangle. Part B reads, what is the length of ML? For this, we'll also look at a couple of different approaches. First, let's look at using similar triangles. First, we'll claim that triangle PJK, the small one up here, is similar to triangle PQR, the big one. And we'll show why that is. First, observe that base JK of the small triangle is parallel to the base QR of the big triangle because JKML is a rectangle. And by the properties of parallel lines, we know that angle PJK is equal to angle PQR. And also note that the two triangles share this top angle QPR. So therefore, by the angle-angle similarity, we have these two triangles are indeed similar to each other. Now that we know that they are similar, we can write the ratios of their side lengths. So we know that PJ, this length here, that ratio with the longer side length PQ should be equal to the ratio of JK, the smaller base, over QR, the larger base. So we have an equation here. Now let's substitute in the known values. We know Pj equals 5 as given in the question. For Pq, we know that it should be 5 plus 50 to give us 55, because Pj is 5 and Jq is 50. On the right-hand side, we have Qr is 66 as given in the question, so we can put that value in. Now our equation is only left with Jk as the only unknown. Now let's solve this equation for Jk. First, on the left-hand side, observe that 5 over 55 can simplify to 1 over 11. So we actually have 1 over 11 equals to Jk over 66. Multiplying both sides by 66, we have that Jk is equal to 6. Now, since JKML is a rectangle, and we know that opposite sides of a rectangle are equal, so then ML must equal to JK and also be 6. For the second approach, we'll use congruent triangles. First, we claim that triangle JMQ, this one right here, is congruent to triangle KRL, which is this one right here. And we'll prove why that is. First, observe that triangle JMQ is a right triangle because angle JMQ here is a right angle. And we know that JQ equals to 50 as given in the question, and KR also equals 50 as given in the question. So those two lengths are equal to each other. Further, side JM, this one right here, is equal to side KL because they are opposite sides of the rectangle JKML. So now we have in these two triangles, the hypotenuse is the same length, and the length of one of the legs is the same length. And these are right triangles. So by the hypotenuse leg congruency, we know that triangle JMQ and triangle KRL are congruent. So because they're congruent, then we can say that side QM should be equal in length to side LR. And we know that LR is 30 because we calculated it in part A. So we have OQM equals 30 as well too. Now let's observe that QR, the entire base of this big triangle, is made up of several segments. So QR equals to QM, this part here, plus ML, the middle part here, plus LR. Now let's substitute in the values that we know already. QR altogether is 66. QM is 30 because we just calculated it. And we have LR is 30 as well because we calculated in part A. So altogether we have this equation in LM. Now we can solve for LM by subtracting 30 from both sides and then subtracting 30 again from both sides, leaving us with LM equals to 6. And we see that this is the same answer as we got in the first approach. Part C reads, determine the height of triangle PJK drawn from P to JK. So to start off, let's draw in that height from P to JK. And we'll call the intersection point with JK A. So we have A right here. And because this is the height, we know that there are right angles at the intersection. Next, we'll extend PA to intersect QR at B. So B is right over here. Now, since JK, we know, is parallel to QR, and PA is perpendicular to JK, then it follows that PB must be perpendicular to QR as well, because PA and PB are the same line, and JK and QR are parallel to each other. So we know that PB is indeed a height of triangle PQR. Now, observe that AB equals to KL equals to 40 because AB then is perpendicular to JK because it's a height, and AB is perpendicular to QR, so ABLK forms a rectangle. So we'll draw that in right here. So there's a ABLK forms a rectangle. Now from part B, we've shown that triangle PJK is similar to triangle PQR. So the heights of the two triangles are also proportional to their side lengths because they're similar triangles. So let's write out that proportion. We have PA, so the height here, over PB, the entire height of the big triangle, should be equal to PK over PR, which is the proportion of the side lengths of the two triangles. Now let's rewrite some terms here. We have PA stays PA. PB, we can write that as PA plus AB. It's just the two segments of PB. And PK, we'll leave it as PK. And PR, we can write that as PK plus KR. It's just the two segments of PR. Now let's fill in the values that we do know already. So PA, we don't know. And on the bottom here, we have PB is PA plus AB, and AB equals 40, since AB equals KL. So we can put in 40 right here. Next, we have on the right-hand side, PK equals to 5. And PK and KR, we know both of those values to be 5 and 50 respectively, so we'll fill those in right here. Now we have an equation with only one variable left, and the variable is PA. And PA is exactly the value that we're looking for because we're looking for the height of the triangle PJK. So let's go ahead and solve this equation. First, I'll simplify the right side. So we have 5 over 5 plus 50. And 5 plus 50 is equal to 55, and we can divide through by a factor of 5. So we're left with 1 over 11 on the right-hand side. Now let's multiply both sides by both denominators. So we'll end up with 11 times PA equals to PA plus 40 times 1, so we're left with PA plus 40 still. And let's simplify this further. We'll subtract PA from both sides, so we'll have 10 PA equals to 40. And finally divide both sides by 10, and we are left with our answer PA equals to 4. So the height of the triangle PJK from P to JK is 4. Part D reads, determine the fraction of the area of triangle PQR that is covered by rectangle JKLM. So to approach this problem, let's go ahead and calculate the areas of both triangle PQR and rectangle JKLM. First, we'll start with the triangle. In triangle PQR, we have the height, which we said in part C is this PB, and we have PB equals to PA plus AB. So we see this PB is here, and we see that it's made of two segments, PA, the height of the small triangle, plus the rectangle height. And we know from part C as well that PA is 4, and AB is 40. So together we have PB is 4 plus 40, which is 44. Next, let's look at the base. The base is QR, which we're given in the question, equals to 66. So the area of the triangle PQR then would be 1/2 times PB, the height, times QR, the base, which equals 1/2 times 44 times 66. Now, I don't go ahead and calculate this to a number yet because I know that I will be taking a fraction or a ratio for the answer. So let me keep this in the expanded form for now. Next, let's look at the area of JKML. We know that the area of a rectangle is just its base times its height. So we have the base, which is ML, and the height, which is KL, which we both know the values of. So KL is 40, and ML equals 6, as calculated before. So now, let's go ahead and calculate the ratio of the area of the rectangle, to the area of the triangle. So the rectangle is 40 times 6, as we have here, and then the area of the triangle is 1/2 times 44 times 66, which is over here. And here's why I didn't go ahead and calculate the two areas into numbers, because here we have a lot of simplification that we can do. So first, we see that 6 goes into 66 11 times, so we're left with 11 on the bottom and 1 on the top for the 6th factor. Now, we also see that we can divide 40 and 44 by a factor of 2, so we're left with 20 on the top and 22 on the bottom. And the reason I only divide by 2 is now we have 22 times a half, which leaves us with 11. So now we have 20 over 11 times 11, which is 20 over 121. And that's the fraction of the area of triangle PQR that is covered by rectangle JKLM.